So we will not hear anything about how computing has gone up and because of which AI is possible now. We will not hear anything about that today. So what will we talk about? Primarily I wanted to speak about how evolution of data has come across in the last 20, 25, 30 years, and how the evolution of data is making many changes into what we do today right now with AI and ML, right? So just so to set that context, and then we'll go into a workshop model. What we will do at the end is you guys will be figuring out your own AI IoT projects. So within your own team, Lalit is going to help me here. And we'll come back with specific models with how you would run with your AI or your IoT project. And how will you measure ROI for it, right? So that's what the framework is all about. So somebody here mentioned that, hey, we are all entrepreneurs, so how do we actually put this into use? And we will speak a little bit about, there's a lot of discussions today about deep learning. We will speak a little bit about why ML is useful and for what reasons it's useful and what does it mean by saturation and for what use cases deep learning is useful and for what use cases ML is useful. So we have a ton of content to cover. So what I'm going to do is I generally speak fast. So I'm going to try and speak fast. So if you guys pardon me, stop me, raise your hands, let me know how we'll do it. We'll finish the content, and at the end of it, we will do the workshop, and during that, we can answer questions. Sounds good? So when the internet came along, it was primarily used for e-commerce, right? So it was more about, okay, I wanted to sell my stuff on the internet and make money. So the whole thing was about transactions. So everything was based on how fast I can do a transaction. When OLTP went into OLAP, it was all about, okay, who am I selling to? What am I selling to? How can I sell more? Right? So it was more, that's when business intelligence came into play. And we were extracting value out of the data that we collected from these transactional systems. Then came along with user-induced machine learning, so where we were creating a lot of data, not just from the websites with respect to Facebook or Yelp or anything, but also from the devices that were in the home and outside. So what we are trying to do is we are trying to make value out of those content. That's pretty much where we are right now. And the value we are trying to get out of the content right now is through ML. So when we go into the cognitive aspects of AI, we go into the general intelligence space. And at that point, it becomes very interdisciplinary. It becomes an intersection of psychology and ethics and a lot more of things which we will not cover. We will cover what is possible today in 2018 with respect to the technologies that we know now and what projects can we do. This is how to connect with me, but in the meantime, I'm trying to find out how many people are interested in trying to start a new project with AI. Half, yes. How many people are already in the process of doing an AI project but want to deliver ROI? Return on investment on AI. Okay? So where does the other half fall in? Can someone just raise the answer? So there was only half of the people who raised hands saying they wanted to do a project. Are the others general learning? Yes. General learning, okay. Okay, so we talked about this, and here, what I also have in my slides is please feel free to take pictures. So there's a lot of surveys and there's a lot of references in each one of my slides, and yes, the slides will be distributed, but it's easier to zoom in the phone and take those references, and it's usually at the bottom, and you guys can go into some of those survey results or also research papers and other references to what I'm pointing to. So this is an actual framework with respect to step 1, step 2, step 3 of what you can do. And what the graph that you cannot read all the way at the back pretty much states what kind of applications are generating value today. So the bottommost reference with respect to MIT and BCG consulting, 1,700 companies of various sizes, mostly big companies, were surveyed to see, okay, you have done AI and IoT so far, and what are the problems that you're facing, and where exactly are you seeing bottleneck? And this is something that we see on a day-to-day basis at eKryp too when we work with our enterprise clients. So it's usually, these are the top 3 things that come out. So first is picking the right problem. Somebody mentioned that this morning, which was good. And how do you define that problem, right? So we'll learn a little bit more about how we define the right problem to pick. And how do we know what kind of data is needed for the type of problem? And how do we know how good quality of data do we have? That's number 2. Then is the measurement. How do we pick projects? So we heard a lot about linear regression, which is pretty much you throw in multiple points in a graph and try and find the slope, and that's what it is. But what does it mean? So if we are going to work on a day-to-day basis and there is something that we are doing, I was missing you earlier. So this is, this whole thing was catered towards if I'm an entrepreneur today, what can I do? So if you're going to work today and some of what the task that you're doing, it just feels a little regular, then you're doing it on your own, but you're doing the same thing again and again. It feels automatic. But then there are other people who are also doing it. And when you take the results of what you have done with the results of what everybody else has done, then we all agree on a solution too. So because it's very, very important that the humans agree on this is a problem and this is the solution, because otherwise we can't trust what a machine produces, right? So now we are talking about very practical sense here. It's easier if we say, put out a picture of a dog and say, is it a dog? Of course we can train, and that takes into a lot of data, and that it takes into deep learning. We are talking about ML here. So that's one way to think about it. How do I take up something that I'm doing today? And when we do the workshop, think about those kind of examples also, right? Think about that kind of example and bring it to the table. How do we define a question? Why did every one of the speakers earlier today said that logical, regression is pretty much what gives the most? I had an amazing conversation with Ranjo a while ago, and most of the statisticians would say that, right? Oh, we've been doing AI for the last 50, 60 years. It's true, because there are ways to go ahead and infer patterns through data, right? So if you look into it, I just took the same example and took it to the various ways to define a question. So the example, how many service requests do we have? It's very much like a BI question, right? Business intelligence question. From there to based on the records, when should I do my preventative maintenance? Then I infer, okay, this motor is running and the sockets need to change every 5,000. Oh, let's take a better example. Car, the manufacturer says to change oil every 3,000 miles, so I'll change it. But then you kind of extend it, saying, you know what, I wanted to extend it a little bit. Then 4,000 is fine. That's pretty much how people do today. If you go to the factory floor, if you talk to people, they would say, oh, the manufacturer said change the sockets every 3,000 rotations or whatever, and they'll keep track. Oh, it didn't die. Okay, 4,000, 4,500, 5,000, now 5,000 becomes the mark. And that's inferential. Mechanistic. How does the output of something, one, affect the second one? And then predictive and prescriptive. We'll talk a little bit more about it in a second, but predictive is what is coming in the future, and prescriptive is what do I do about it? Here is a definition of predictive and prescriptive. Predictive is pretty much knowing what will happen. So I have a good example would be, who likes to travel? A lot of people, right? So if you wanted to know from place A to place B, what are the low-cost ways to get there? So let's say you're searching for flights. You'll see a ton of websites that will compare the various websites, various prices, etc., and will say, okay, from A to B, here are the sites, here are the prices, right? Most people do that. What Southwest does is a little different. Have you guys seen this monthly calendar? And within the calendar, it will say, oh, okay, instead of the Tuesday, if you go on, instead of the 12th, if you go on the 18th, right? So it will be $20 less, whatever it is. But Google Flights, flights.google, takes it a step further. It will actually go and say, instead of taking this route or instead of going this particular day, if you go on a Wednesday, you will save $100 or $120. So it's taking in from one to another and inferring what exactly it means, taking it a step further, a little nudge further, right? So, and in the prescriptive case, there is, okay, so if I know something is going to fail, what's the point, right? It's good that I know something is going to fail, but how do I extend it further? To go and say, is this a time to repair it? Or after how many repairs do I need to really refresh it? Maybe something is failing already and it's also predicted to fail. I might as well give this person a new equipment and save me time. That gets into the prescriptive aspect of it. And this example applies to every single aspect. And more applications are getting into the prescriptive mode. There's most of ML applications today are in the predictive mode, but they are getting into the prescriptive mode. I think Sumit touched a little bit on that. So how do we, our full step to problem definition, right? So what are the abnormal patterns in my data? And we already talked about the various types of questions. So within the question, so I'm going to state, okay, this is the problem I'm going to solve, and here is a particular question that I'm going to form, and it's an actual business case. And when we form the actual business case, we are also going to go ahead and say, here's the enterprise unit, or here's the set of people. Even if we are startups, we are all selling to big companies. So here is the exact, who's the buyer, who's the person who's making, getting the benefit out of it. So we know exactly what is the ROI. We start from there. Right? How are they going to do it? And I'll have some examples on it too. I'll go through some examples and how do we define that. And then what are the OKRs? So objective key measures in which I would measure it. Oh, by the way, what you see on the right side top are the 3 problem areas that originally that was identified that we'll go through step by step. So data wrangling process, it's interesting. As we are working with more and more enterprises, ours is a product, so we do it across very many devices. So we have a lot of transfer learning within our product. But as we are working with enterprises, Sumit was talking about the amount of data that they have is less. Even for people who have high volumes of data, they only utilize 1% of the data that they have collected so far. Ideally, what we have found is 33% of the data that is within an enterprise that can actually be used. So what we have is the various steps that we needed to take to clean the data to feed it into a model. And you guys all heard about this, right? 85% of the data scientist's job is cleaning the data. This is where the 85% boring job happens, but this is the most critical piece in getting the data ready. So ImageNet has, did anyone know how ImageNet came about? And I'm not talking about an ML example, but how many people are familiar with SETI? Science of extraterrestrial. So it's basically when people SETI started off at Stanford, right? So when people wanted to figure out extraterrestrial, so it was happening in one location. Then they said, okay, everybody uses a laptop, and they're probably utilizing only 20% of the computing power in the laptop. How do we go ahead and divvy up the work across the various computing power to have different people share the data and also do the computation and provide us back the results? That's kind of how SETI came. How did ImageNet came about? Fifi Lee, what she did is they went ahead and did exactly the same. Go ahead and submit images of dogs. So millions and millions of data went in. In an enterprise situation, none of this is going to be possible, right? So it's not going to be millions of data. You have to garner value from the existing data that you have within the enterprise. So what are the steps that you needed to do, and how do you clean out the data and figure out what is the most important piece of the data that you can feed into the model? So I have some examples here with respect to data quality and some of the scenario exercises here. So let's take the lettuce head example. There was a company that wanted to figure out what is the right time to pick lettuce. to pick lettuce heads from the field, right? So they went to Google, they looked for places where they can find input data. They found nothing. So what did they do? They went to the farms, they walked aisle by aisle, taking pictures of lettuce heads, right? So they have the most repository of lettuce heads with dirt. And they use that learning to figure out at what point they need to pick lettuce, and then they could use the models, similar models, to transfer to picking strawberries, maybe, right? So it is, how do you make sure, and even in picking lettuce heads, how do you make sure where values are getting missed, where there is imbalance? There is actually, each one of these buckets, there is a research paper. I didn't put the reference on it. I will when I was preparing for this workshop. So if you look for these things, there is a research paper with respect to what does missing values means and what does it and how do you go ahead and measure it. So there's an amazing article on it. So and it is important to take in the data and say when is it skewed? When am I ignoring the boundary conditions? And somebody asked the question of ethics, and we'll talk about it a teeny bit before, later. But then what are the outliers? When do I use the data? When do I discard the data, right? So all of that needs to be figured out. But if you think about so this is a study that was done. If you think about, everybody talks about volume of data, and that's very important in deep learning. But when it comes to ML, what is more important is variety. Variety is the most important than volume of data, right? So it is because let's take a parking example, right? So is Spot Hero. Anybody uses Spot Hero? It's a fabulous application to figure out parking, right? You get it, especially if you're going into the city, it will have a parking space reserved for you, and you go in and you park. So how about you embed Spot Hero on top of the weather conditions and on top of what are the events that are happening in the city? Oh, there's an RSA conference happening. There's an open world happening. That is going to make, change the patterns with respect to the parking lots in the city. And so that's where the variety of data comes in, right? Just to give you guys an example. Looking into the data, there are certain things that these are huge blunders that has actually happened in the industry. Does anybody know about the Pokemon Go example? Tell me.
Pokemon Go?
Yeah. What was the error that happened in the first version of Pokemon Go?
Well, I know that people are going all over the place and then leading in the accidents. That's what I remember.
So what happened is African American neighborhoods were ignored. And because they didn't have anybody in the development team, there was no input that was fed with respect to African American neighborhoods. And LinkedIn, when it started giving out job recommendations to females, it didn't provide higher level jobs as recommendations to females. These are actual blunders that did happen, but it all got fixed promptly. But those are the things to take care of, right? So if you think about autonomous cars, most of autonomous car driving modeling is all supervised learning, right? So you're giving inputs. So classic thing is nobody in the team was wearing high heel shoes. So it didn't recognize high heel shoes as they were crossing the street or whatever. So these are things to think about when it comes to bias. And it's good to think about it in the problem definition time rather than later on, because these are the things that would affect the results, right? And early on, we talked about how bias like this would go into credit checks, insurance, all of that. We don't want that. Go ahead.
Diagnostics would you use to even recognize, my data is actually biased or incomplete in the first place?
the problem definition has to be much, much, much more detailed, right? You have to know which demographics you are taking it to, or which area of the enterprise you are affecting. Do I have all of the data? And some of it you will figure by trial and error. But the best part is in deep learning, we have no way to explain what it is. In ML, you do have a way to explain what it is because you have the data and you can figure out, oh, I didn't use the right set of training set. By the way, Professor Yasser's HealthTech class is highly rated, and he's one of the first people who came in and who said 10x times data is needed. So to train the model, somebody asked that question earlier today. So, so that is all deep learning, but in ML, it depends on the type of data and type of problem, but his class is amazing if you guys haven't seen it. Of course, Andrew's is also good. While we are talking about classes, I wanted to give you a couple of references. I just wanted to finish the thought. One was Analytics Vidya. She does a fantastic job for people who know SQL and going into machine learning. KD Nuggets, anything that you want to do, look into time series data, KD Nuggets is amazing. And data.gov has a lot of public data, so that you can use and create Kaggle projects and you can compete. So some of those resources I just wanted to throw. I wanted to remember to put that out.
What was the name, sir?
Data.gov. Data.gov. So in terms of regulation, we have to watch, again, while defining the problem, can I ask for their religion or can I ask about their sexual orientation? That's, the regulatory bodies are not going to allow that. So that's something to keep in mind with respect to what are the boundaries of the problem and what is the solution you'll go against. A couple of scenarios. So I do have the links with respect to the actual details on how they came up with these scenarios and what level of algorithms they used and how they did it. Please do. It's an amazing bedtime reading. It's really good. So Netflix, even what they figured out is if people take over 90 seconds searching for a movie, then they lose customers. So that's, you could call it customer sat. But how do we improve search results? But by improving search results, they actually turn that and they put in a dollar value to how they measure ROI, right? Because if you think about the traditional way of measuring something like this, you could say, oh, it's a customer sat issue, or but they actually put in saying, if it is 90 seconds, if it gets to 60 seconds, or if it gets to 30 seconds, how will that be? How will that experience be? What is the cost of losing a customer and at what given point? And added up all of it, and they came up with an amazing number. And if you look into their algorithms, and if you look into how they do it, it even goes to the packet level. So, based on the device and the location and my preferences and everything, they would be streaming data through. But then even the next block of data, they are looking into high quality, medium quality, low quality. Even with the next block, they get it down to that level with respect to, okay, so going through a tunnel or getting right next to Moffat. So let me get to the low data, whatever it is, right? So they go to that level. Kiva, click-to-ship time was reduced. And again, it's a fabulous example because after Amazon acquired Kiva, it took 2 years for them to recognize the value out of Kiva, but it's just the unbelievable value. They got the cost that they paid to Kiva right off the bat, right? But this is a way to go ahead and measure ROI within projects. So I would highly suggest taking a look at these two use cases. Somebody talked about culture earlier, but that's something that's interesting, right? If we are making decisions for a doctor, if we are making decisions, if machine is making a decision, then who are the people who needed to adopt it so it can be actually rolled out into the field, right? So something to think about. And those things are also called out. And training, within the enterprises, that's a common thing. We go and ask our sponsors, okay, you're taking our product, but who are you going to train? How will the rollout be, right? So are we going to start with one geographical location before we get it to the world? How are we going to do that? So it's not none of our business, but that's the only way adoption is there with respect to the product. The other thing most of ML companies do is there is an approval process by a human being. So machine makes a decision, and then there is an approval process by a human being that says, yes, I agree with it, which is still fast. There's no way we can look into that level of patterns of data and come up with anomalies and patterns and take it to a prescriptive action, but then there's a human that goes in and says, okay, I agree with this action. So that gets a lot through the culture aspect of it too. So here is why everybody talks about supervised learning, why logistic regression is, it's really not logistic regression, it's actually classification. As you can see, this is a very, very, very recent data that came in, and I'm actually interested in, I haven't done the homework to compare this with the data that came in 4 months ago, but what are the types of methods that people are using today within their AI environments, and where are they actually seeing economic value? And I did not have to call out transfer learning separately, but I did just because it's important to recognize that that can be used as an intermediary step before we go into unsupervised learning. But most people are into the supervised transfer learning part. And on the right here, we talk about how clustering, continuous estimation. So for example, there is a company that does, where do you need to do real estate investments, right? That's what they are trying to figure out. So for real estate investments, they look into various kinds of properties and they cluster them. They classify them, and then they cluster them into different groups, right? Some multifamily in tier 2 cities with this particular rentals or whatever it is, and then they come up with their predictions. So that's a common methodology that's being done. Another example, consumer example to think of. So as soon as we go and say, okay, I have defined my question, I've defined who the question will benefit. I've also figured out here is the set of data that I'm going to utilize, and what are the boundaries of the data that I needed to have and or don't have that I needed to bring in. Who within the company will be impacted? Once we have all of that, the next thing is to really figure out how are we going to go ahead and implement it. So this is one way I look at classifying applications today, right? So, and I heard a lot of exchange of words between ML and AI today. So, for the right word to use based on the discussions today would be AI application types instead of ML application types. But if you look into Vicarious and DeepMind, check them out and check out how they do the deep learning. It's completely two different ways of trying to have a machine learn, right? That's those are, I call them the pioneers. Autonomous systems is pretty self-explanatory. New use cases, taking in a use case that was never there before and trying to bring that up, right? So the lettuce head example before we talked about, that is a fabulous example. The other thing is patient rehabilitation. So there is not a whole lot of data that's there for rehabilitation, and because most of the patients get discharged right after the procedure. So bringing in that data and collecting that data to be able to come up with a brand new use case is a new use case, but collecting the data, like how Watson Health is doing, are the collectors, right? So there is a friend of mine that does the company where you take in 10, you just put in 10 pictures. It doesn't matter what it is, and it gives you a personality of who you are and what you could be, and based on the colors of it, right? So they are collecting new set of data based on a use case that they are trying to solve. So those are the collectors. The reason collectors and automate workflow like eKryp is in different colors is, if you think about it, the rest are longer term, right? Platforms are fantastic. Somebody asked a security question early on. Figuring out APIGI, right? APIGI, just Google about APIGI. If you think about security, if you think about image, if you think about video, voice, those are all high level means it requires a lot of data to solve those things. Platforms do that very well, right? To come up with standard ways to put that out to the rest of the people. So something to think about. So those, but automating a workflow, I do a certain action again and again and again. Is there any way I can use AI to automate, right? So one of the examples is a car infotainment maker uses an industrial robot to put screws in the car infotainment when it gets affixed to the car. If the torque gets off a little bit during the process, they have to throw away that part completely, right? So how do you realign the torque in real time? So think about examples like that. So anything that automates the workflow or anything where you're collecting brand new data is something that's very unique. By the way, only 7% of the people use homegrown solution because it is laborious taking in a platform and then figuring out how you're going to solve the problem, which is why even platform vendors are very, very interested in AI ML applications. So when we look into the buy criteria, or when we are thinking about creating it for somebody, here is the buy criteria that most of the enterprises use, right? So we have, the application has to take into account the data wrangling process for whatever problem they are solving. They have to do the data wrangling. They can't have the clean data provided. And the interesting part is anytime, so this is another reason why people go to solutions outside of what they create, is because an external vendor is less biased than they are. So that's another reason. And it has to be collaborating. So I don't know if I have that slide, but if you think about today's platforms, it's all system of records, right? ERP, CRM, ITSM, put in and take an enterprise and all of those buckets of data that's sitting. And the new platform is a system of intelligence that sits on top, right? So it has to be easily integrated into the rest of the data within the ecosystem. That's something to think about. And what we have on the right that's a graph that's showing where exactly the adoption and the benefit would be and where exactly we are seeing it. Everybody knows that healthcare will see a lot of benefits, but it's been slow within healthcare. Whereas high tech, they are much more open into taking in the data and figuring out where the value is. Okay, so this is nothing different when it comes to the deep learning part or the ML part. So how do we learn? We take our whole learning, then we make some mistakes and multiply by our learning rate, new inputs from the environment, and then the new learning comes in. So there's nothing different in this, but what is important is the type of question that you come up with. How do you evaluate how it is tending towards the ideal scenario? That's what needs to be figured out. Somebody asked a question with respect to ML saturation. Who was it? Okay, that person is not there. The reason ML saturation doesn't matter is let's say you have 90% predictive. Let's take a common example. Let's take what everybody knows, predictive maintenance. Let's say for 90% of the equipment that you have, let's say you have 10,000 equipment in the field, 90% you have high rates of prediction. Does it even matter if you have only 200 engineers who are servicing it? Not really, because the 200 engineers can go to 10,000 equipment anyway. So they are more interested in the first 200 or the first 400 or first 600, whatever that may be that they can solve, right? Something to think about, which is where ML saturation is happening, but it's not necessarily a bottleneck with respect to real world scenarios. Make sense? Any questions here so far? So what are all the steps that we talked about? We talked about the right question. How do we define the right question? And how do we get the data and quality data? And number 3 is how do we measure ROI? So we talked about this. So now let's do a group discussion. So if there is a table that's very sparse, go ahead, join another table. Lalit, can you help me here? And pick a scribe, time, a person who can time it. If we can time for 10 minutes, Praveen, that would be good. And then here's what you're going to do. Come up with, talk amongst yourself, take 10 minutes, come up with, here's a business case, here's the owner, this is how we measure it. The reason we didn't put OKR is because it's too short a time. All we are trying to do is just understand the framework here. We are not going to come up with deep problems that we will solve, but just something that it can be an AI problem instead of a statistical problem is what we are thinking here, right? So, and then how do we measure ROI? So, and as a group, it will be great to hear what you guys think. So pick a presenter and you guys can come and present. So that's a thinking here. Any questions, any clarifications, comments on this exercise?